everybody doing? Good? All right, let me make sure you're still with me. I know it's getting to that low sugar point of the day. Yeah, well, I have a curious case to share with you today. I'm Antonio Bayona, by the way. I am, as you know, with Starr Associates. My time with data, as a data analyst goes back to about 10 years. I've had the privilege to work in a variety of industries, learn from a variety of disciplines, and with the common thread being sales and marketing, analytics, really. But the example I have for you today goes back to year one when I was working for an airline. And if you had a chance to go to that link that John shared earlier, what we're looking for here is the curb check bags workbook. I'm going to put that on here. Let's see if I could full screen that so you can see what I'm talking about. And so what you're seeing is a business scenario where the airline, month to month, you have your total number of bags that passengers check, and they're tracking the proportion of those that were checked at the curb, because there's a small fee for that, and they're looking to understand, okay, are we doing better or worse at this month to month? And this is purporting to show that performance. Basically, it's saying here's our performance. So just looking at this chart, though, if I asked you what month they have standout performance, what would you say? September? That's interesting. Okay, I heard June as well. So those are some of the common answers, particularly June. Huh. Very good. Very good. You nailed it. You beat me too. So let's dive in here and explore why that is. Why is October actually the best month in this result? So I'm just let's go to new sheet. And by the way, what we're talking about here today in particular is regression analysis. Okay? And for that, we're going to begin with looking at the total curb checked. So total bags, we're going to drop that into columns. We're going to call that the independent variables, a technical term. And we're going to take curb check bags, drop that into rows. And to start with, we're not seeing much, right? It's just, 1 point. Well, you saw earlier, John mentioned there's a feature here about aggregated measures. Right? So what we really want to see is we want to plot out every single month and compare the results month to month, one to another. Now we start to see a clearer pattern, right? So what we want to draw across here, using the analytics features in Tableau, there's a trendline option. We drop that into, we're going to start with linear. This is simple regression, one variable to another. And drop that in there. And this is giving us now the linear regression model for that line. This is basically drawing your attention, first of all, to the R-squared value at 0.90. So the technical term is the coefficient of determination. The other way to look at it is it's just telling you the relative strength, right, of the change, between the values in the x-axis, total bags, to the curb check bags. So in the linear model, it's basically saying 90% of the change in curb check can be explained by the change in volume in total bags. This number is typically anywhere between near 0 to 1. 1 being the strongest relationship. It's basically saying to you that 100% can be explained. This one's pretty close. And it's also showing what appear to be at first 2 outliers. The concept of an outlier is any value that doesn't fit the model, right? But if you look a bit more closely, there's more going on here, because see how these these points kind of intersect, right? Let's go back to our values here. I'm going to take date, drop that into labels. We're going to look just at the month so we can understand and more clearly what we're seeing there. And the percent curb checked. Okay. And now I'm going to take this model and I'm going to try to find basically what we call the best fit. When we look at regression, we're talking about what best explains the relationship between these two values. Linear one gets us close. Okay, if we did logarithmic, not so much. The R-squared actually dropped. Let's try exponential. Okay, interesting. We got a much better fit, right? It's starting to make sense. With one outlier being October. And we can also more clearly see why October is an outlier here than in the previous chart. Because if you look at its peers in that same volume territory around 300, right, total bags, August and November, I believe, yeah, right next door to it, about 300, it's about 288, so it's a little bit less, and yet it achieved a higher percentage result, a higher proportion of curb checked bags. So it's an outlier, but it's actually, in this case, it's good, because it's telling us something different actually happened in that month that we're not gleaning, at least immediately, from this chart. So that's what revealed, in fact, and just to give you a little background on this, the reason we also know that that's significant is the business in this case affected a change in that month, a process change to try to drive that number up, but looked at these results, some people did, concluded, well, there's nothing remarkable going on here, and then in November and October decided to switch that off when they were actually winning, doing things the other way. So that's one of the dangers and one of the values of this kind of analysis is to reveal things that aren't immediately visible sometimes. So one thing we could do with this, going a little bit deeper into what we see here when we highlight the curve here, there are a number of things going on. We've talked about the R-squared, which you can see in this case has gone up to 0.95. So we're getting almost close to 1-to-1, right? Beneath that, you see a p-value. So the p-value, basically the basic term for that is the predictive value. Anywhere when it starts to get below 0.05, it's basically trying to tell you this is a highly predictable pattern, right? So in every other month, what we're seeing here is not performance, it's business as usual. This is an organic result. It's not the result of any business change or any effort. It just kind of happens, right? As passengers come in, as that peak goes up, as the volume increases, there's a little bit more increment of how many check at the curb because just lines build up and such. There's kind of like a natural dynamic, right? But it's highly predictable. Above that, we see what is called the point slope formula. And I'm going to switch over to the visual here just to better explain that. So, not sure why it's doing that. Okay, there we go. So what Tableau is giving us there in that formula is basically a predictive model, if you will, where we can take a total value, plug it back in to an equation, a linear equation, and predict an expected outcome from that. So now that we have that baseline and we have somewhat of an understanding of the dynamics, let's go back to this example and see what we can do with that. Because clearly what was missing here is we're not comparing to a benchmark. it's not really talking about performance, it's describing an outcome. But it's not really telling us whether we're doing well or we're doing poorly compared to expected value. Some might say, and I've had this question many times, well, why don't you just go back to last year and look at year over year and season? Well, the issue with that is we have things going on here, right, specific to the business. Seasonality is one of them. Obviously, it's travel, so some months are going to be better than others naturally. The other one is that certain aspects of the airline business, in particular, like capacity, can drastically change what the total outcome here is for any given month. So, for instance, if you have one flight, your capacity goes up. Now you have more planes, more people flying. You might look at a total number of bags that's 400 this year. Last year, if you had more planes, it could be 800. So you're not really comparing apples to apples anymore. So we need something a little bit more dynamic. So going back to this example, the first thing we want to do, talking about the concept of outliers, is we're going to exclude October to get us to a much cleaner model. And when I hover over here now, you're going to see 99. It's pretty dead on, right? Okay, so now we have a formula up there that we think is pretty reliable, but there's one more thing to check. One more thing I would offer you here. One is the sample size is very small, obviously. So ideally, you want to have a larger scale sample to really, once you get to the stage where you want to use it as a predictor. This is just a basic example I have here. It's the only one I could offer you for this view. Also, we want to take just a quick look at what's called residuals. So residuals, now we're talking about the model is looking at the actual values that are occurring, and then it knows what the predicted values are. We want to compare the difference of those two. So just basic subtraction. Yeah, so we know what the actual values are. The model is calculating a predicted value based on those. When we subtract them, what is the difference? What is the net? Right? So let's go back to I'm going to remove this temporarily because what I want for this is the full data set, right? And there's a little trick in Tableau you can do to quickly get to the residual values without having to do a lot now. So with all these items in here, we're going to go to worksheet, export, data, and you can see it's going to try to create a Microsoft Excel Access database. It's going to dump that in there. Rename that. It's going to come with a default table name for it. You can read that's changeable. You can rename that. I'm just going to leave it default for now, and then tell it to immediately after the data exports to just connect to it, and you can name the data connection as well. I'm going to give it a second to process that. Okay, so there we have our data connection popping up, and I'm basically going to create another plot. Now, based on, you see these temp values, where you have your predicted. I'm going to go through the same steps. Okay, so this is the residuals plotted. To answer your question, what you see here, you had the 24.71 value, and when I subtract my predicted value, or my actual, sorry, it's my predicted. If I subtract my actual, but my residual is 10. 35 minus 10. Okay. Why is this important? Well, if we had a much larger data set here, it'd be a little clearer, but basically what we have is, we want to see a scattered pattern, a random pattern here. That tells us that the model is good, it's relatively good, it's stable. If we start to see other patterns such as a curve, like a U-curve in here, up or down, that's telling us other things. The U itself could tell us that there's a lurking variable. This is for much bigger models. This is very simple. Okay. But for now, we're going to go with the assumption that this is a good model. Let's subtract October again. And I cheated a little bit here. Sorry. Sorry, folks, give me 1 second. There we go. Am I missing something? Yeah, it's formatted in white.
Yeah, you have, go back to where you were. And
Oh, the font. My bad. Excuse me. Okay. In this view, we can see that the actual value of curve check came in around 12% for October, but according to the model, should have been 8%. So we're 4 points above.
Just reaffirming what we already knew, that something happened.
Right. This is kind of another way to just to quickly check it. Right. So that's one way we can use the points slope formula as a predictor. And what this could be, this is comparing actuals to actuals, but what it could be is a forecast as well. If you have forecasting totals, you engineer that back into the formula, this pattern could be the forecast of expected for the next few months, which is, in many cases, will be of more value than just a gut estimate or something that's, calculated or engineered from some other, derived from some other past value that may or may not be relevant in the current model.
So you want to turn this into money. So then, if whatever they did in October is right, and it might be right. If you were forecasting, say, hey, well, if we did whatever we did in October, and you just kind of what you were doing, say, forecast it out, and kind of convert that into how much money we should make.
Yeah, definitely. That's a great question too. Ultimately, this is about revenue, right? It's about how to convert this to money. I can't share the actual dollar figure with you, but over the course of a year, it's hundreds of thousands, of dollars for. I'm talking business one location, not company. So it makes a difference, especially for an activity that most passengers underuse, and it could be added value. So that was the case of check bags, if you will, and I hope you took something from it that you can use.
Would you be able to synchronize the axes there?
Oh my God, that's right. Meant to do that. Meant to do that. Overlooked that. Yeah, it's a little bit clearer now.
The expected value formula.
The expected value formula.
You got that from the model, strat model.
I'm sorry? Yes, that came off right from, when you hover over here. Mhm. It'll tell you exactly the curb check bags being the Y value and equals 0.07228086 times total bags plus the 1.09.
So is your background more actuarial, statistical, and then you became more into the EI space?
Another good question. You know, like many of you, I've worn many hats
Uh-huh.
over the years. And then much of what I've learned is just necessity. You know, you have a business necessity, you have cases that need to get deeper insights into, and you learn. You learn by doing. At least that's the best way I learn. So I started just running reports, just compiling data and running reports and stuff. But really my interest was understanding what was going on in the business. Right? So I got more and more involved with discussions around business strategy and how we're using data to drive business decisions, not just churning out, what we call data puking. Right? Not just churning out numbers for the sake of numbers, and that's how these things kind of came into my view. And this was a first early example because, I said I was really grateful to work with really smart people. I'm still working with smart people. And it was my boss who saw this chart at a QBR meeting and brought it to me and said, I don't think this is right. Like, this isn't telling us anything, right? And that's where we got suspicious, started to look into it this way, and we're able to present back to management, hey guys, we dropped the ball here, basically. So we went back to measuring it a better way.
Yes, I guess what I'm getting at is to look at data from that type of, linear, all that kind of stuff, that's not the typical business analytics, that's more.
It's used in marketing. It's used in marketing.
Oh, marketing?
It is used in, my sales and marketing background, when you're looking at especially predictive factors for conversions, for, response rates to certain things, if you're doing mailings and things like that, and you want to look at it.
Forecasting or projecting what the success will be.
Correct. A big use for this is propensity to purchase. If you have good data, and you look at your customer profiles and look at certain aspects of that, and start to flow to the top, profiles of customers that have a high propensity to buy a certain good or service, and you can target them more accurately. So the two current tools, my top tools, Tableau obviously is one of the bigger ones, and the other one we use Ultras, which you're all familiar with as well.
So for you, this business problem that was presented, was the initial visual built out in Tableau, or you just replicated it in Tableau?
I replicated it because this goes back to, interestingly, pre-Tableau days.
Okay, yeah.
This was in Excel
Yeah.
originally. I think when this came up, Tableau was like a startup concept. It wasn't even a brand.
So the reason I asked that is that you said your manager kind of pointed out we missed something here. It's not showing us anything. This is kind of a guided exercise. Obviously, you're showing us what your
Yes.
final result was. How did you? You didn't show us every step of your process that got you here, or was that?
No,
the
this
bait-
was
that the
pretty
bait?
much it. This was pretty much it. I mean, by the time we got to just the scatter plot,
Yep. That's when you noticed.
we already knew there was something more going on here.
Yeah.
Just this alone was like, okay, October was a success. And then, we kind of looked at it other ways to validate. Because, as I said, the correlation of the p-value alone can be misleading if other factors aren't checked. Another one that I didn't really go into here, but it's, for the sake of example.
Remember the spot, so let's come back.
Model degrees of freedom. So if you're not talking to a statistician, they're going to point that one out as well as another aspect beyond residuals to check validation. That is a major mathematical deep dive, just to explain some of that, but basic, it will give you an idea of in this case, it's saying two, it's saying that up to two values can possibly, the change in two values up to, can possibly impact the result, the prediction. And you had a follow?
Yeah, so from the other chart, I can tell that October was more successful. Here, I can see it's an outlier,
Mhm.
but how can you tell it's successful from here?
Comparing it to its peers. So more apples to apples than apples to oranges, because if we look at the other months that fell into that total bag range,
Oh, so 9%.
right, this would normally be down here next to, it would probably be sitting as the model implies.
Okay, I get it now. So
Yeah.
just from this dollar amount, just say it's $1 bag, if they're checking 9% of the bags that come through, as opposed to 12%, 12% more money.
It's more, the model would say that data point would be sitting at about 8% normally. Yeah. This is scenarios. Thank you. Any other questions, thoughts? I know there's a big stats guy back there who's skewering this, but you know, it's a basic, it's a basic example, and it's one that is relevant in the real world.